Hello everyone, this is Harry Gill and this is the third part of the stream topic. In the first part, we saw the concept of the stream. In the second part, we saw how to create a stream. So we only saw the source bit of the pipeline. And in this part, we will look at some of the terminal operations. As you might remember from the previous discussion, the source of the stream will not start producing the elements or the data until a terminal operation is present. So starting this video, we will have complete working pipeline that we can run because it will have both source and a terminal operation. So these are the terminal operations that you need to be aware of for the exam. In this video, we will discuss all of them until the forEach terminal operation. We will leave out reduce and collect. And the reason for that is the reduce and collect are relatively complex. And if I have to merge them in this video, the video will become pretty long. So I have decided to make a dedicated video for reduce and collect terminal operation and will upload in future. There are a few important points that you need to learn about each and every terminal operation. The very first one is, what is the return value of the terminal operation? The second is to answer whether is it a reduction. Reduction is a special type of terminal operation in which all the elements are combined and the output is a single value. So for example, counting the elements in a stream is a reduction because we actually go through each and every element and then count them, and that output that we get is just a single value. Similarly, averaging is another example of a reduction. And also, we need to know how will a given terminal operation will behave for an infinite stream, which means we should be able to answer whether that terminal operation will terminate the infinite stream or it's not able to terminate the infinite stream. So let's start with the count terminal operation. So as the name suggests, so this terminal operation will count the number of elements in a stream. So let's jump into the IntelliJ and start writing the program. I'm creating a class called countExample and creating a main method in it. I'm going to create an integer stream and I will have that stream produce a bunch of integers. And now I'm going to call count terminal operation on that stream. The return type of count is long, so I'm going to print the value that is returned by the count method. Now I'll save and run the program. And the output is 10. So which means this particular stream contains 10 elements. Now let me create an infinite stream. And as you might remember from the previous video, this is how I can create a stream of random numbers. Now I have a stream that will produce an infinite number of random numbers. Now let me call the count method on this infinite stream. And let me also print what it returns back. And now let's save and run the program. So as you see here, the program is still running. It didn't print the count of the infinite stream. The reason for that is the infinite stream is currently keep on producing the random number of the doubles. And the count method is still waiting for the stream to finish because the count cannot tell how many elements are there until the stream actually terminates. So the count is keep on counting the numbers and the infinite stream keep on producing the numbers, which means the count terminal operation does not terminate the infinite stream. Now let's head back to the PowerPoint and answer all the questions that we need to for the count method. So as I mentioned, the return value of the count is long. Is it a reduction? The count method is a reduction. And the reason it is a reduction is because it goes through all the elements in the stream because it has to count. So it goes through all the elements and produce one value. So that is why the count terminal operation is a reduction. What happens for the infinite stream? It does not terminate. So as you have seen, the program was still running, and until you explicitly terminate, the program will not terminate because count does not terminate the infinite stream. Now let's move on to the next terminal operation, which is min and max. As the name suggests, the min will return the minimum element from the stream, the max will return the maximum element of the stream. How does it decide what's min and max? For that, we will have to pass a comparator in the method based on which it will decide what is min and what is max. Just to keep the program short, I have created a new class called min-max-example and created an empty min method. I'm going to create a stream that will produce a bunch of integer numbers. And on this stream, I'm going to call the min method. As mentioned, the min method takes a comparator. So we need to give it a comparator to tell how to compare in between two elements of the stream. Since our stream has integer, the integer class itself has a compare to method. So I don't have to write my own. I will just use compare to. The return type of min and max is optional of the type, and the type is same as whatever the stream type is. So in this case, since it's an integer stream, the return of the min and max will be optional of integer. And since it's an optional, we will have to get the value out of the optional. If you want to learn more about optional, I have already made a video and I'll link that video in here. And now we have got whatever the minimum value is, and I'm going to print that value using system.out.println. And now I'll save and run the program. So as you see here, the value that we print is 1 because 1 is the minimum element in the given stream. Now let me change it to max and save and run the program. Let me also change the println argument from min to max, and now save and run the program. It prints 100, so which means the 100 is the maximum value in the stream. Now let's see how does min and max behave for infinite stream. So I have created a stream that will produce infinite number of doubles, and now let me call the min method and see the output. Now let me save and run the program. So as you notice here, the program is still running. So what's happening here is, when we have to calculate a minimum or a maximum within a set, you have to know the whole data. Until you have the whole data, you can't decide which one is minimum or maximum. So just like count, the min method is waiting for the stream to terminate so that it can decide what is the minimum value in that whole stream. So which means the min and max method do not terminate the infinite stream. Now let's head back to the PowerPoint and answer the questions. So the return value of min and max is optional of the stream type. If it is an integer stream, then it's optional of integer. If it's a stream of strings, then it's an optional of string. Is min max reduction? Yes, it is. And the reason for that is because the method has to go through all the elements in the stream and then decide the minimum or the maximum. So it goes through all the elements but return only one element back. So min max is a reduction. What happens for an infinite stream? As we saw, the min and max actually waits for the stream to finish before it can decide the min or max value. So min and max do not terminate the infinite stream. The next terminal operation that we will look into is findAny and findFirst. So the findAny will actually find any one of the elements in the stream and return back. findFirst will find the very first element of the stream and return back. Now let's jump into IntelliJ and see an example. For this program, I'm going to create a stream that will produce strings. And for this stream, I'm going to first call findFirst. And as you notice, the findFirst will return an optional of the type. So I'm going to call the .get method to get the actual value from the optional. And now I'm going to print the value that is being returned. And now let me save and run the program. So the program returns Java. So Java is the very first element of the stream, and that is why the word Java is returned. Now let me change the program, and instead of using findFirst, let me use the findAny. findAny will return any one of the element from the stream. So this is useful when you don't really care about which specific element you want. You want any one element from the stream. And this method is more useful in the parallel streams. In the sequential stream, you will always get the very first element, but in parallel stream, you could get any one of the elements from the stream. And the response in the parallel case is unpredictable. Now, I'm going to create a infinite stream, and let's see how these methods behave in that case. And first, I'm going to use the findFirst method and going to save and run the program. So what happened here was, so we had an infinite stream. So the infinite stream produced the very first element, and we actually got that element and printed out, and the stream got terminated and our program exited. So this is a very first example where a terminal operation has the ability to terminate the infinite stream. And now I'm going to change the program for findAny, and I will save and run the program. So the program did exit just fine. So which means the findAny method as well terminated the infinite stream. Let us now head back into the PowerPoint and answer the questions. So the return value of findAny and findFirst is optional, and the type will be same as the type of the stream. Is it a reduction? It's not a reduction. Even though it returns single value, the reason it's not a reduction is because it does not look at all the elements of the stream to return the output, and hence we can't call it as reduction. So what happens for a finite stream? So both findAny and findFirst do terminate the finite stream. Now let's move on to allMatch, anyMatch, and nonMatch method. So these all method takes a predicate as inputs. So what these methods do is, depending on which one we call, they either check whether that predicate is true for all the elements, or is it true for any one element of the stream, or it's true for none of the elements. Let's jump into the IntelliJ and look at the example. For this example, I'm going to create a list of strings. And since all these methods takes a predicate, I'm also going to create a predicate. And the predicate that I'm going to create is to check whether the first character of the string is a letter or not. And now I'm going to create the stream of the list and call the method anyMatch with the predicate that I just created. The return of all these three methods is Boolean. So I'm going to just print the returned value of these methods. Before I run the program, I'm going to call the other two methods as well and print their values. Just want to highlight one thing here. In this case, on all these three statements, I'm actually creating a new stream for each statement. As you might remember that once a stream is consumed, we can't reuse that same stream. So that is the reason I created a list, because it's easy to create a stream from a list, just less code to type. Let's evaluate the program before we run and see the actual output. So in the very first statement, in the anyMatch and that predicate, so we are saying that if any of the element matches that predicate, which means if any of the elements first character is a letter, then return true. So the return of anyMatch will be true if any of the string that we have in our list starts with a character. In the second one, we are saying that all of the elements of the stream needs to start with a character. And as we know, the second element here, which is the number 2, doesn't start with a letter. So allMatch is going to return a false. The third one, it says nonMatch, which means none of the element in the stream should start with a letter. But as we know, the first element monkey and the third element chimp starts with a letter. So the return of nonMatch will be a false. Let's now save and run the program. And as we expected, the output is true, false, false. I'm now going to create an infinite stream of strings, and the generator that I have given here is, it will create a string called chimp. So now this is an infinite stream, and when it starts producing, it's going to produce the chimp word infinite number of times. Now let me first use the anyMatch with the existing predicate. And when this statement will run, the infinite stream will start creating infinite number of strings, and the value of those strings is chimp. The very first element comes, which is chimp. The very first character is C, which is a letter. So in this case, the anyMatch will actually become true in the very first element, and hence it will terminate the infinite stream. Let's now save and run the program. Now let me actually write another predicate, and this predicate I'm going to write which would be a kind of opposite of the first predicate. In this one, I'm checking that the very first character of the string is a digit. And now let me change the predicate of anyMatch, and I will save and run the program. And as you're seeing here, that the program is not ending. And the reason it's not ending is because it's anyMatch, it's waiting for the very first element whose first character is a digit. We know, due to the way we have created the infinite stream, that is not going to happen because all the elements are chimp. So this program will just go on and on and on, which means to answer that if anyMatch will terminate the infinite stream or not will really depend on the data of the stream. So we can't say whether it will terminate or not terminate for sure, and it depends on the data. I'm going to stop the program, and I'll also comment this line so that our program doesn't get hung. In the next example, we are going to use the nonMatch method. And I'm going to save and run the program. And as you notice, the nonMatch for the predicate 2 is not ending, because so we are producing that string whose first character is not an digit, and it's actually waiting for the stream to end so that it can decide whether none of the element matched. We have written the program, and the way we have written it is, we know that it will never happen, but Java doesn't know that, because until the next element is produced, it cannot guess what that would be. So that is why the nonMatch is still stuck, because it wants to make sure that none of the elements of the stream starts with the digit, which we know is not going to happen. So I'm going to terminate the program. So I'm going to modify the program and use the first predicate. So that first predicate checks whether the string starts with the letter or not. And now I will save and run the program. And as you see, the program ended with the false value. So the reason that nonMatch returned false value is, in this case, we were giving a predicate and we were saying that this predicate shouldn't match any of the elements of the stream, but we have at least one of them that match. So the nonMatch method returns back without checking any further elements, and it reports back as false. So just like anyMatch, whether nonMatch will terminate the infinite stream or whether it will not terminate the infinite stream will really depend on the data of the stream. Now let's check the third method, which is allMatch. And the predicate that I'm going to pass to it is, it will check whether the string starts with a letter or not. And I will save and run the program. And as you notice, the program is still running, it's not terminating. The reason that our program is not terminating is because allMatch is actually waiting for the stream to end so that it can decide whether the predicate matched all of them or not. Now I'm going to modify the program and use the second predicate. And the way I will read it is that return true if all of the elements are starting with the digit, otherwise return false. The very first element, which is chimp in our case, doesn't start with the digit, it starts with the C. The very first element it sees, it returns back. So again, just like anyMatch or nonMatch, the allMatch, whether it will terminate an infinite stream or not, will really depend on the data of the stream. Now let's head back to the PowerPoint and answer the questions. So the return value of these methods will be a Boolean. It will tell whether it matched or not matched. Is it a reduction? No, it is not a reduction, because in some cases it does not necessarily has to traverse through all the elements to answer the question. So that is why these methods are not reduction. What happens for the infinite stream? It really depends. So it sometimes terminates, sometimes it doesn't terminate. That depends on the data of the stream and the predicate that we pass. The last terminal operation that we will look into in this video is forEach. The behavior of the forEach is it takes a consumer and it will run that consumer for each element of that stream. So let's jump into IntelliJ and see the example. For this example, I'm going to use a stream that will produce the strings. And I'm going to call a forEach, and as mentioned, it takes a consumer and I'm going to pass the println consumer. So which means I want to go through each element and print it. And now I'm going to save and run the program. And as you notice, it prints all the elements one by one. And now let me create an infinite stream of doubles. And on that stream, I'm going to call forEach and I'm going to print the elements. I will save and run the program. As you notice here, the infinite stream is producing the random doubles infinitely, and the print method is simply printing them. So which means the forEach method will not terminate an infinite stream. Now let's head back into the PowerPoint and answer the questions. The return value of forEach is void, which means it doesn't return anything. Is it a reduction? So it's not a reduction because it doesn't give a single value back. What happens for an infinite stream? For an infinite stream, it just keeps on running the consumer, but it doesn't terminate the stream. To summarize the discussion, these are the terminal operations that we have discussed in this video. We will discuss reduce and collect in the next video. If you like this video, please hit the like button or let me know if there are any suggestions that you would like to give me through the comments. That is all for this discussion. I will see you in the next one. Bye-bye.